This is Trekzone's Talkin Science.
Welcome to Talkin Science. Let's get straight into the week's headlines. Airbus Space and Defence have announced a continuing commitment to the Australian space industry by partnering with the Department of Defence to develop the resilient multi-mission Space Starshot. Under the agreement, SpaceAustralia.com reports that the team will advance the development and maturation of leap-ahead technologies in support of the Australian Defence Force. It'll also explore new operating concepts and support the development and space qualification of Australian sovereign payload and satellite components. This partnership represents an investment of more than $40 million in satellite technologies. The Space Launch System in assembled flight configuration for Artemis 1 will now roll out to Launchpad 39B tomorrow, Australian time. The bump up on the schedule is a rare treat for spaceflight enthusiasts, with the original planned date of Thursday. So just a couple of days ahead of time, but still a rare treat. The Artemis 1 stack will roll to the launch pad atop the Apollo-era Crawler Transport 2. Now, while it only has to travel 6.4 kilometres from the assembly building, the journey will take 8 to 12 hours, according to previous NASA statements. Speaking of Artemis 1, 10 secondary payloads have been loaded into its cargo hold as she prepares to lift off from Cape Canaveral at the end of the month. 2 of those 10 are critical to maintaining a human presence on the lunar surface: Lunar Ice Cube and Lunar Polar Hydrogen Mapper, a cubesats designed to hunt out all-important water sources. NASA Exploration Research and Development Manager Mark Lupi-Seller said Lunar Ice Cube will help pave the way for human missions through significantly less expensive robotic missions and by addressing water dynamics on the moon. The Polar Orbiter Hydrogen Mapper will be heading to the South Pole to study previously identified potential areas of water ice. Space.com is reporting that Europa's ice shell could be much purer than previously thought. They say that studying unusual processes of how frozen water accumulates below ice shelves here on Earth could hold lessons for the exploration and habitability of Jupiter's moon. Frosal ice forms in supercooled water columns and floats upward to accrete onto the bottom of ice shelves, while congelation ice grows directly from under the ice itself. Intriguingly, the researchers determined that ice formed by these processes retains just a fraction of the salt from the water from which it formed. The new information could aid the calibration of instruments aboard the forthcoming Europa Clipper mission, which is expected to launch in 2024. Arriving at the icy world 6 years later, it may find this purer form of ice, resulting in differing penetration levels of radar waves and radar beams and all that good stuff. Astronomers hope to use pulsars scattered around our galaxy as a giant gravitational wave detector. These gravitational waves are flowing through us as I speak, formed by merging black holes, supernovae, and even the Big Bang itself. We've spoken to Professor Tamara Davis from the University of Queensland about these. While there are incredibly sensitive instruments here on Earth already, the LIGO and Virgo detection arrays, and they have detected gravitational waves, we can do more because those ground-based detectors have a hard time finding the low-frequency waves that can take up to a few years to pass through planet Earth. Enter pulsar timing arrays. Using a subset of pulsars known as millisecond pulsars, which spin ridiculously fast, and through some very advanced mathematics, astronomers can measure their relative distance to Earth, which is affected by a gravitational wave. At least that's the way the theory is going. Now, that's an incredibly simplified version of what goes into these calculations, and everything is in orders of magnitude smaller than I can comprehend. All of that is to say that there are some very smart folks out there trying to find more gravitational waves, and I hope they do. Let's bring it back home to Australia now, and a new instrument developed through collaboration between the UK's University of Warwick and Australia's Monash University is set to be built at the Siding Springs Observatory and will address the gap between gravitational wave detectors and electromagnetic signals, keeping this gravitational wave theme going. Space Australia reports that a new instrument known as the Gravitational Wave Optical Transient Observer, GOTO, is set to be built at one of Australia's most iconic dark sky regions, the Siding Spring Observatory, located in north-central New South Wales. The instrument is made up of 2 autonomous telescope mount systems, each featuring 8 individual 40-centimetre telescopes that cover a very large region of the sky. Utilising the light-collecting power of a combined array of 16 astrographs and giving a powerful 800 million pixel output. What Godo will be looking out for is its electromagnetic counterpart signal that emerges when very high mass objects, like binary pairs of neutron stars, follow in spiral orbits, eventually merging in a huge explosion known as a kilonova. The light from these explosions is very important as its signature contains information about how some of the heaviest elements in the universe, like gold and platinum, are created. Australian scientists and researchers led a program to develop a new spectrograph that has been installed on one of the most powerful telescopes in the southern hemisphere. This story from spaceaustralia.com as well. The Gemini High Resolution Optical Spectrograph, or GHOST, I love astronomers and their acronyms, will now be able to analyse the spectral data of many astrophysical objects in high resolution. When light from stars and other astrophysical objects passes through a gaseous medium, elements within the gas absorb certain wavelengths of light, which are recorded on spectrographs as gaps or dark bands in a continuous spectrum. The higher the resolution of the spectrograph, the finer the detail that can be made out. GHOST is housed deep below the Gemini telescope and is fed by optical cable. The multinational project is set to provide some incredible detail in the years ahead. Well, Dr. Brad's here on the first Tuesday of every month to bring us a roundup of the biggest stories across the past month. And I've got your bite-sized wrap of the week, the other 3 Tuesdays, just like this one. Brad will be back in 3 weeks. Trekzone membership is available via the join button under each video on YouTube or via the trek.zone/support, plus Trekzone's on Twitter, Facebook, Instagram, and your favourite podcast feed. Find us, like, follow and subscribe, and for one-time contributions, click thanks below our YouTube videos or head over to the trek.zone/PayPal. Thanks for watching Talkin Science. I'm Matt Miller. I'm going to see you in the comments.